Hi, everyone. We've set up this Being an Engineer podcast as an industry knowledge repository, if you will. We hope it'll be a tool where engineers can learn about and connect with other companies, technologies, people, resources, and opportunities. So make some connections and enjoy the show.
Engineering's not just about technology. It's about people and being that constructive part, that service-oriented part of the world.
Hello and welcome to another exciting episode of the Being an Engineer podcast. Today we are thrilled to have Dean Michael Jensen on our show. Dean Jensen received both bachelor's and master's degrees in electrical engineering from Brigham Young University in 1990 and 1991, respectively, and a Ph.D. in electrical engineering at the University of California, Los Angeles in 1994. He's been a professor at BYU since 1994 and is currently dean of the Ira A. Fulton College of Engineering. He's taught courses in electromagnetics, high-frequency circuit design, and signal processing for communications. Dean Jensen, thank you so much for being on the show today.
Thank you for having me. I'm excited to be here.
All right. So how did you decide to become an engineer?
It's not all that complicated. My father was actually an electrical engineer, worked in the aerospace industry in Southern California. I grew up tinkering with electronics next to my dad, was good at math, physics, other sciences, and it just seemed like a natural path. So I just followed in my father's footsteps.
Okay, that's easy. Yeah. I find that, interestingly, our fathers have a lot of influence over individuals becoming engineers. I ask this question to everyone, and it's common to hear my father influenced me this way or that way. Not necessarily that they were all engineers, but my dad said at the living room table during dinner, "What are you going to do?" And I said, I'm not sure. And he said, "Oh, you should consider being an engineer." And I thought, great, I'll do that. And it turned out to be a great fit. So certainly thankful for our fathers.
You know, your anecdotal evidence matches the research that shows that our parents and then maybe uncles and aunts or other relatives are the number one influencer on sort of the academic path that we take.
Oh, how interesting. I hadn't heard that statistic before. Okay.
Yeah.
Well, terrific. Well, Dean Jensen, you've been a professor now at BYU for almost 30 years, and I think we all, basically understand the role of a professor, at least from the context that we're aware of as students, right? Professors teach students. But outside of that, what is the role of a professor? What's your day-to-day like outside of teaching?
Yeah, as a faculty member, I think most students know that faculty are also engaged in research, particularly at an institution like Brigham Young University, where I am, or other major research universities. So there's a lot of research activity. The beauty of engineering is that we get to do that research side by side with students. So all of our research projects involve students working with us, usually getting paid. So it's kind of a good gig. We use undergraduate and graduate students, all throughout the spectrum of sort of preparations in our research activities. And beyond that, of course, it's mentoring student teams. There's a lot of service work. We serve on committees at the university that make decisions about curriculum, about people's promotion and tenure, policies at the university, hiring, all of those things. We all serve on committees to sort of just manage the business of the university.
Wonderful. Now, I'm curious, and you can speak from your own direct experience or maybe anecdotally from what you've heard from others as well. Do you think that most individuals who go into academia do so mostly to teach or mostly to do research, or is it kind of an even split?
It's probably a fairly even split. I mean, at BYU, we fortunately have faculty who are passionate about both. And my experience at UCLA was very similar. The faculty loved teaching and being in the classroom up to a certain point. They don't want to do that full time because they also love their research and their student mentoring. So I would say at a research institution, we're clustered around the center of enjoying both, some favoring research, some favoring teaching. As you look across academia, of course, there's universities that don't have that research expectation. And there you're getting people who are very passionate about the teaching and probably less interested in the research part of the career.
That makes sense. Okay. Well, speaking of academia, that was your chosen path after graduating. And you also have a business that I think we'll talk about as well. If I understand correctly, and please correct me if I'm wrong, you went first into academia and then later on started the business. What made you choose to go into academia as opposed to directly into industry?
Yeah, so first of all, you are correct. I chose academia before industry. That wasn't my intention as an undergraduate student. I planned to follow my father's footsteps, probably go work in the aerospace industry like he had done, maybe after a bachelor's or possibly after a master's. And then as a senior in my undergraduate, I got an opportunity to engage in a research project. Had a blast. Thought, I think I want to continue this. So applied for a fellowship from the National Science Foundation that helped fund my graduate education, received it, decided to stay for a master's, enjoyed that, decided to go on for a Ph.D. It's once I got done with that, I still hadn't decided to do academia. I had planned to go work for a Bell Labs or something like that. They were very big at the time. It was a great place to conduct research in industry. But I got this opportunity to come back to BYU, my undergraduate alma mater. I thought, if I'm ever going to do it, now is the time to do it. Took the opportunity, fell in love with it, been here almost 30 years.
Oh, that's wonderful. I'm sure the students are grateful for all of your service there. If there are students listening to this and maybe they're thinking about, what am I going to do? Am I going to go directly into industry, or maybe I'm curious about going into academia as well? What are some things that they should know that maybe they're not aware of or don't fully appreciate about going into academia?
Probably the first and most important thing to know about academia is it's not as easy a job as you probably think it is. Most of our students look at us and say, well, you teach 1 or maybe 2 classes per semester. Wow, that's easy. That's a good gig. But the research expectations and the other demands on our time, most of our faculty here at BYU work at least 50 hours a week. And getting things like research money is hard. Now, of course, your life is different at a school that doesn't have a research expectation. And you'll be teaching more and not doing so much research, and maybe a little bit lower stress, also probably lower compensation. Beyond that, of course, that's sort of the negative of being a faculty is that workload. What's the benefit? Engaging with students, constantly learning and challenging yourself through your research, constantly figuring out better ways to make the material come alive to a student. There's nothing more rewarding than working by a student and seeing the lights come on. So that's the fun of it.
It sounds a little bit like being an entrepreneur, where you get to figure some of these things out for yourself. You're not just given, do this and follow it step by step.
I would say that's astute. We like to say as faculty that we're kind of like entrepreneurs, but with the safety of a regular salary. So,
great way to put it. Yeah. Okay. Well, going back to the research expectations, how does a professor know if he or she is meeting those expectations? Are they, rigidly defined somehow?
Yeah, they're clearly defined. We have documentation on all the expectations, and there's a lot of latitude for sort of moving within the lanes that are defined, but it's pretty clear what is required and expected.
Is the expectation, without divulging any specific details, but is it as a research professor, you're expected to bring in a certain amount of money each year to fund the research, or create a certain number of patents, or license a certain number of IP out to companies, something like that?
So the main output of the research endeavor, and let me make it more the graduate education endeavor, because our research goes hand in hand with graduate education. The main output is students, right? So working with and mentoring students is the number one criteria. Now, of course, your productivity and it's all done with students, is measured largely by the number of publications in good venues that you have each year. So that would be the largest kind of measurable thing that the university looks at, the committees look at. Funding is an expectation, but essentially funding is an input to the system. Do you have enough fuel to drive the research? And that's the funding. And for some faculty who are very experimentally focused, that's a lot of money. For some faculty who are more computationally focused, it's quite a bit less funding that's needed. And we don't distinguish between that. Do you have enough money to support the kind of research program that you want to maintain?
And is each professor responsible individually to go out and find that funding?
Yes, although you can imagine there's lots of collaborations among faculty.
Okay.
So they certainly partner up and write joint proposals to get funding and work on them together. And that's a very fruitful and rewarding way to conduct research.
So if the primary objective is to grow the student engineers, it almost seems like the research is just a tool. It's not just a tool. I'm oversimplifying here, but is that a correct way to think about it? That the research is kind of a tool to facilitate that main objective of growing students?
Absolutely. The primary objective, especially at BYU where we are, is student mentoring. And it's a vehicle or a tool, as you say, to be able to mentor those students. And
Wonderful.
Just give them that additional. We have other objectives, of course. We're engineers. We want to improve the world. We want our research to make an impact and improve the lives of people. And we also, frankly, in all institutions, institutional reputation. We want to enhance it. We want students to come and we want people to know that their degree is from a quality institution, and our research output is one of the ways that the quality of our institution is measured.
Yeah. I was speaking with a gentleman, actually a previous guest on this show, and I asked him, he's a very experienced, very senior level engineer working predominantly in the medical field, but I asked him, where are you seeing the best engineers come from? What universities? And he had no idea where I had gone to school, BYU. And he listed 2 schools. One of them was BYU. And I was just so delighted to hear that, what a great testament to the alma mater.
Well, I'm delighted to hear that as well.
Yeah, definitely. Well, you're currently dean of the College of Engineering. How has your day-to-day changed being dean? What additional responsibilities have you had to take on, and what have you had to let go?
That's a great question. I mean, my career has changed dramatically since becoming dean, where my function is largely administrative at this point, and that includes budget, hiring, all of the HR throughout the college, human resource, any kind of hiring and firing, I'm involved. Policies, helping the department chairs through their challenges. So most of my job is that kind of administrative, lots of time in meetings. What have I had to let go? I haven't really taught a class since I've been dean. And I miss it, but it's what I've had to give up.
Yeah, I'm sure the administrative side is fulfilling in its own right.
Coming to a point in your career where you say, now I can contribute at a different kind of a scope, that's rewarding. And I've enjoyed it.
I can understand that. Certainly I'm not where you are in my career, but I've progressed enough that it's really a lot of fun to mentor some of the younger engineers and provide some guidance and leadership there.
Absolutely. I'm glad you're enjoying that. I think all of our graduates and it's just engineers everywhere should see that as part of their role. Arthur Brooks wrote a great book on this, which is the later we get in life, the more we need to see our role as mentoring and helping and less trying to be that innovative, fast thinker, because frankly, our brains stop supporting that and start supporting the mentoring much better.
Oh, that's an interesting way to look at it. Yeah. How has engineering education changed between when you were a student and today? And what do you think maybe still needs to change?
It's a great question. Academia doesn't change fast, and nobody's surprised to hear that. Has it changed since I was a student over 30 years? Yes, of course it has. We're much more hands-on, much more using the opportunity in classroom to not just lecture, but to pause, maybe work on something together that helps cement those ideas and help them stick in the minds of our students. I think we're better in laboratories to bring relevant experiences, things that are relevant to industry today, even though we know they'll evolve. At least they come out with some of those fresher tools and capabilities to run them. So I think we're better at that. I think something, you ask what still needs to change. I think something that maybe we've actually gone downhill on since I was a student and now is our focus on helping the students know how to communicate. Some of those softer skills that, as you know, as an entrepreneur, have helped you in your career. I know they have. And we've sort of lost some of that as we've added more and more technical content. And while I don't have a solution to it, I know that our students are suffering because we're not doing a good job of helping them be communicators, both written and oral.
You know, that's so interesting. I see some of the same thing with some of our younger engineers. And I like to tell them and others that if you are the smartest guy in the room, or girl, technically, you know all the equations, you know all the physics, you're a whiz with CAD, you can do all those things, there is still kind of a limit to how far you can go in your career if you don't have those soft skills, the communication skills. On the other hand, maybe you're not the most technically gifted engineer, but you're good enough. You're 80, 85 percentile, somewhere around there, but your communication skills are amazing. There's almost no limit to how far you can go. Have you found that to be the case as well?
I love your analogy. I think you're absolutely right. You only need to be a certain level of sort of raw technical capability, and it's got to be high. But once you get beyond that, it doesn't help unless you've got those communication skills. Absolutely true.
Yeah. Well, I think back to when I started college, and if I'm being totally honest, I probably was not very well prepared. I kind of cruised through high school. I didn't need to try that hard. And then I started at BYU and I realized, oh, I'm in a different league here. I need to step my game up. And it was a struggle for me. I don't feel like I naturally excelled. I enjoyed my experience there for sure, but it was hard for me. I look at some of the students now, and even high school students, and their skill level from a technical standpoint is so far beyond where I was at that stage. Are you seeing that as well with new engineering students, that their baseline skill level is higher than what it was 20, 30 years ago, or is that not the case?
No, I think that's generally true. We've pushed math farther down in the curriculum and say high school, even middle school, at least what's available to the students, than when I was, for example, a student, and maybe even when you were. And so they certainly come with that kind of preparation. I think what's a struggle for most students is what you experienced, and most of us experience. Maybe we're top of our class and we don't have to work that hard in high school. And then college is kind of a shock to the system and in what the expectations are. And we still see that today, right? And in fact, maybe in increasing sort of acuity or severity because of the mental health challenges that some of our students are coming in with and our inability to really help them through all that added stress that they're just not used to.
I love that you mentioned the mental health. That's something that we see a lot these days, not just in engineering students, but in youth and adults in general. When I was college age or high school age, mental health, it just wasn't something that was talked about. It wasn't a topic. And I'm not sure if that was the case because it wasn't such a problem or because people just didn't feel comfortable talking about it. They're probably both are true to varying degrees. Do you feel like that has become more of a problem these days, or we're just better at talking about it these days?
I don't know that I have a full answer to that question. The research seems to support it's a combination. So yeah, it's much easier to talk about and kind of less of that sort of stigma associated with it compared to when I was, these students' age and probably when you were as well. So that's certainly true, but there also seems to be trends in today's culture, approaches to parenting, There's no doubt the research is clear. Social media is having an impact here. That students are coming in facing a different set of challenges than, say, when I was a student, and we're struggling to help them navigate it.
I have a hunch that there is some correlation between the diminished ability for students to communicate effectively, those soft skills, and the social media and mental health issues. It'd be interesting to dig into that at some point.
Yeah, there is research on it, but I'm not an expert on it, so I would hate to speculate, but there is definitely connections here.
Well, speaking of education and preparation, what can students do to best prepare themselves for an education in engineering?
The easiest thing is what we've already talked about. That's the easiest answer, right? Math is a language, and when engineers are fluent in that language, then sort of everything comes from that. So not shying away from taking as much math as you can, and then of course physics or chemistry, depending on sort of you want to be mechanical, electrical, chemical, and focus on that. But I would really say that I think those are kind of a given, and everyone understands that. What I really wish students would do is really find ways, if high school is not challenging them, then find ways to challenge themselves. And I don't really care if this is, additional academic work of some kind, maybe going over to the local community college and taking a class there, or some sort of a concurrent enrollment or maybe it's something on the athletic field or something like that, something that really forces them to schedule their life and work hard and do all those things, because really, like you mentioned before, our students are coming in academically well prepared. They're just not always emotionally prepared for what college throws at them. And I like to see students who have taken steps to maybe stretch themselves a little bit that way and be a little more resilient to hard things in their life. And I think that's probably my favorite preparation they can do.
Can you think of specific examples of what students have done to make themselves more emotionally resilient?
So I personally love, even though I'm not really a team athlete guy, I'm sort of a mountain biker, and more individual things like that. But when I see these kids come in, having been involved in team sports, whether that's football or whether it's the tennis team, which are very different kinds of sports, but just that connection with the team and going through challenges as a team, it appears that it creates a resilience. And I'm sure there's other things, competitive chess. I'm sure schools have all kinds of things like that allow them to sort of work together, to have some setbacks, and figure out together how to dig out of those setbacks. Those are the good kinds of things to do in their lives.
Wonderful examples. Thank you for sharing that. Well, I'm going to take a very short break here and share with the listeners that teampipeline.us is where you can learn more about how we help medical device and other product engineering or manufacturing teams develop turnkey equipment, custom fixtures, and automated machines to characterize, inspect, assemble, manufacture, and perform verification testing on your devices. Today, we're speaking with Dean Michael Jensen. And Dean Jensen, I'd love to hear more about the company that you started, this radar manufacturing company. When did you start it? Why did you start it? What is it that you do there?
I'll try to make a long story short. Actually, another faculty and I started our first business in 1997, 1998. It was a software company, and we'd gone out to Hewlett-Packard at the time to beg for some licenses of software for our students to use in the classroom. And they said, sure, we'll give you that, but we also would like your expertise. And so we started writing software for Hewlett-Packard in one of their CAD tools, just bringing our expertise sort of their CAD tools. That was our first business. But it could only grow so far. So in 2000, we got this opportunity, got some investment capital to start a hardware company. And we chose building radar. It was one of our expertises. Building radar to do traffic management at intersections and along highways to monitor cars. And 2000, the company's called Wavetronix, and it's been a fun ride ever since.
Incredible. Wow. What's one of your proudest accomplishments there at Wavetronix?
It's a good question. Obviously, all the products we put out and having them be successful in the markets are proud moments. But I think as an educator, what makes me tick is seeing the growth in people. So creating another environment where I've seen even some of my own graduates from BYU, but of course we hire from all over, seeing engineers and frankly other people from other disciplines, trying to create a community, an environment where they can thrive and they can continue to grow and learn and not just make a living, but really feel a part of something exciting. I think the proudest thing for me is to look back on this experience and look at these employees and realize I'm making an ecosystem that helps them to thrive in their life. So I don't know that it's an event, more as sort of an observation of what the last 23 years, has done.
Yeah. Well, you mentioned that professors at BYU are often spending 50 plus hours a week working. I'm guessing, I could be wrong here, that you maybe even exceed that a bit with being dean and having a company that I'm not sure to what extent you're directly involved in the management of that, but probably at least some. How do you balance your academic career with your industrial career?
It's a great question, and it's a tough one to navigate. At BYU, we have some restrictions on what I can and can't do with the company. And so it sort of keeps it in check how much time I can spend. I have taken 1-year leave of absences from the university, the first one to start it and another one kind of mid-career to spend full time in the company, or at least largely full time. But, my first priority is, of course, the university. That's my commitment. I'm getting a salary to do that. And then I, give a little bit of additional time to help with the company, mostly management board kinds of functions, higher level functions, not day-to-day management.
Yeah. Okay. Well, going back to education for a bit here, is there anything that you wish students applying to the College of Engineering would understand before they decide to go the path of engineering?
Well, obviously, we want them to know the rigors of a university education. And I think you and I know that engineering sometimes can be seen as even more demanding than other majors. And I think they need to be prepared for that. But what's probably I'm more passionate about them knowing, and I wish that students and faculty would understand, is the transferability of the skills that an engineer gains. So I go down, for example, and meet with management consulting companies and tax like Ernst & Young, right? Or these kinds of places who want to hire engineers, not because they have engineering problems that they need to solve, but they find the analytical thinking, the problem-solving skills, which can transfer over not just to technical problems, but organizational problems, people problems, being very data-driven. There are a lot of people around the world who want those skills that they find in an engineering graduate, and these jobs are not sitting in a cubicle designing, an aircraft wing for Boeing. Now, that's a fine job, and a lot of our graduates, that's the way they go, and they love it. But I think there's a lot of people who would like maybe to go in a different direction than that, who would really benefit from an engineering education. And that's a message I wish we could get out, because we get a lot of demand for engineering graduates in non-traditional engineering jobs.
That's a wonderful message that resonates with me. I have found my engineering education to be incredibly versatile because it taught me how to think, right, analytically, hopefully logically. In fact, a few years back, I remember sitting with a friend of mine who runs a one-man design firm, and we were talking about business and how he manages his company, how I manage mine. And he was lamenting that, I have to spend so much time administratively because it's just me there, right? I have to wear all the hats. And I suggested, well, what if you were to hire an admin? And this friend of mine, he's not an engineer. He didn't go through university to become an engineer. He's industrial designer. And he says, well, yeah, I could do that, but then I'd have to pay the administrative employee, and I don't want that extra expense. And we kind of went through some numbers and said, well, if you could bill an extra 10 hours a week because your admin is doing that part of the business, you're billing at a much higher rate than what you're paying your admin. And overall, you actually make more money doing that, right? And the lights kind of went on for him. He thought, oh, okay, yeah, I see it. And I think that's just a great example, a simple example, but of how engineers are trained to think much more analytically and find numbers, something that we can measure and use those to make decisions.
Yeah, I love your example. It's a great point. Absolutely. You may not know that the Harvard Business Review every year ranks the top 100 companies in the world. And there are years where the CEOs of those companies, the majority of the companies' CEOs come from engineering backgrounds. Now, there's other years where we're more like second, maybe to business graduates, but we're always in the top 3 in terms of the CEOs running those top companies in the world being from engineering backgrounds.
I am not surprised to hear that. Yeah. What a gift it is to be an engineer.
Absolutely.
Well, if you had to guess, or maybe you know this for a fact, what do you think is most challenging for engineering students these days?
Beyond the mental health issues that we've discussed, which we're seeing as kind of the primary challenge, beyond that, just technically, the rigors, the rigors and just being able to balance when everything seems to be due and all the midterms are all at once, plus a lab is due and something didn't go right in the lab. That's always a challenge in engineering school, and our students just need to be equipped to tackle that. It's rigorous, but there's no better preparation for the rest of their lives, so it's worth it.
Yeah, I maybe didn't fully appreciate that when I was there. I remember there were two or three times specifically, I recall when there was a test that I did really poorly on, or I was in a lab and I just couldn't figure something out and I wanted to give up because it was so hard. And luckily I didn't. But I think going through that experience was really helpful in preparing me for other just even general life experiences outside of even work-related experiences. But doing hard things is extremely beneficial for us because of what it prepares us to handle later on.
I couldn't agree more.
Let's see, beyond just the kind of technical educational aspects of university, what's one thing that if students learn this lesson before they graduate, you'll feel like you've really done your job as an educator, or the school has really done its job in preparing these students for their careers?
What I'm going to say probably won't surprise you as an alum, but on the entrance plaque to the university, one of our kind of big monuments out there, it says, enter to learn, go forth to serve. And that's part of the mission of BYU. And I don't think that most graduates from BYU, or really most of the schools around the United States, appreciate what a great gift their education has been. You look just internationally and the distinction that education brings. And I wish that our graduates would go out more focused. And so I guess I'm admitting that we're not doing as well as we should in this, helping our graduates understand that now their responsibility is to serve the world. That doesn't mean they can't make an income, and even a good income. But I want them to see that they have an obligation. And rather than judge those who weren't able to get as good an education as they were, that they go out and recognize where they can lift and serve and use their education to build the world, rather than just build their own, sort of stability and family life. And so I wish we were doing better at that. And if we could really do that with every graduate, I think then we have really succeeded in our college mission.
Wonderful. Wonderful. Well said. I'm going to pivot a little bit here and talk about industry, and specifically, how have you seen industry working well with engineering colleges? What are we doing well, and where do you think that we can improve?
Well, I think basically everybody's got. All the universities with which I'm affiliated or have had interactions do really well in interacting with industry. They've got recruiters. We've got recruiters that love our graduates. They come in big numbers, hire large numbers of students, help us understand maybe where the industry is going. I think those interactions are really, really good. And I think one of the things that, of course, this is going to sound very self-serving being on the side that I'm at, but I go to Europe and I have collaborators over there. And those guys, my faculty collaborators over in Europe, they work side by side with industry on research projects. And industry supports maybe a doctoral student, an employee to come in and work at the university while they're still doing part-time day work at the company and trying to integrate that, their responsibilities at the company and their research at the university. And it becomes this very integrated experience for these students. We, because of intellectual property barriers and the like in the United States, we're terrible at this. But I see how impactful it is for the students and the companies and the universities, this ecosystem that's created over there. And that's something that I wish that we could replicate here in the United States and do better at.
Yeah. Okay. Well, I know we've been looking for opportunities to integrate more with educational institutions, and we have had some success here locally. There's a ASU Polytechnic campus that we've worked with a little bit, but it's really a great when you can find the right fit. It's a great opportunity for both organizations to benefit from.
Absolutely, yeah, and I know that Polytechnic campus there at ASU. That's a great program to collaborate with.
Yeah, I love how hands-on they are there. It's really it's a lot about doing, not just learning about doing, but actually doing.
Absolutely.
What is, if you can think of one, what is one of the proudest moments that you have had as an educator? The more specific, the better. I'd love to hear a story if you can think of one.
Well, unfortunately, it's probably more focused on my graduate students than on my undergraduate students. As much as I love to see the lights come on in the classroom and see that impact and have graduates come back to me and tell me how my class impacted them, and of course that all makes me proud. Really, I tend to work with the graduate students more in a one-on-one sort of fashion. And I have a particular one who, he'd done an undergraduate, he'd had me for a class, he'd gone off to work at a company, he was writing device drivers for this company, and he just was bored. And so he contacted me and said, hey, I'd like to come back. I'd like to come back and do a master's degree. He did that. He said, boy, this is really fun. I'd like to stay on and do a Ph.D. I said, great, let's do it. And I watched him transform, from kind of a guy that was writing device drivers to what he's become now. He's working for a national lab now, and he's thriving. To see that value add that came through that mentoring experience and what he's able to do now and how he's able to lead, and that is just extremely rewarding. Now, I'm singling out one. I could give a dozen stories like that of seeing that value add in a student through that one-on-one mentoring. For me, that's what it's all about right there.
Yeah, it really comes down to people at the end of the day. I'm going to wax philosophical here for just a minute, if you'll humor me. There was a time several years ago when I was riding my bike early in the morning out for a ride, and I remember seeing the sun coming up, and there were just a little scattering of clouds out there. And it was this beautiful sunrise, right, with the light scattering through the clouds, and blues and pinks and purples, and just a very beautiful scene. And I remember thinking to myself, this scene would not be nearly as breathtaking if the clouds weren't there, if it was just the sun and the sky. And then relating that to people, how life wouldn't be nearly as joyful and enjoyable if it weren't for the people around us that kind of reflect, the learning, the transfer of feelings and experiences the way the clouds did with that sunlight. And I thought that was an interesting analogy. We talk a lot about joy here at Pipeline. The purpose of Pipeline is to promote joy in the lives of our team members. And it really comes down to people at the end of the day. Engineering is fun. It is. We have a great time doing it. But without the people there, it wouldn't be nearly the same experience as it is with these wonderful people that we get to work with every day.
I love your philosophical waxing there. I think that's so true. That's why I'm an educator. It's about lifting people.
Yeah. Well, just a couple more questions here, and then we'll wrap things up. Specifically within the context of your role as an engineer, what is one thing that frustrates you, and conversely, one thing that brings you joy?
Frustrates me. Oh, probably my inability to solve problems in an optimal way. We solve so many problems, and I want to find the perfect solution. But you really can never find it, right? And the perfect is so vaguely defined. And so for me, I want to find that perfect solution. And when I have to settle for what I consider a less than perfect solution, it frustrates the heck out of me. So there you go, my biggest frustration as an engineer. What brings me joy? Still solving that problem. To me, there's nothing more gratifying than solving a problem, and especially when I get to do it with other people, whether it's students, whether it's colleagues, all of the above. When we sort of have that moment of, I think we've got this. I think maybe we've been working for a year. I think we've figured this out. It's working. I don't know. I mean, that's just almost as much joy as sort of raising your children and seeing them succeed. It's just, it's a great moment.
Absolutely. What a magical feeling. I like to say that the highest levels of joy come from doing really hard things with people that you really care about.
Absolutely. Love it.
Well, let's see here. Maybe the last question for all the students who are listening to this episode today. What is the one or maybe two things that you really hope they take away from this conversation?
I'm glad you gave me two, not just one. I think it's been clear that the value I place on people, whether that's mentoring, working together, just recognizing that value of people, that engineering's not just about technology. It's about people at so many levels, whether that's collaborating, whether that's the problems you're solving to lift the lives of people, all of that. So people, keep it focused on people and being that constructive part, that service-oriented part of the world. So that's sort of one. I think the other thing that I hope that students will remember is that an engineering education is not just about technology. We already talked about how transferable the skills are, about how engineers are playing roles in the world that people would consider non-traditional for their education. And even for our students and graduates who want to take that very technical path, to recognize all the ways through their lives that problem solving, that problem diagnosis skill that they have, how they can apply it really in their families, in their faith, in their community service, and in their professions. I hope that they'll recognize the great gift they have from an engineering education.
I love that. Agree 1,000%. Well, Dean Jensen, what a delight this has been to talk with you today. Before we end, is there anything else that you'd like to share that we haven't had the chance to cover?
No, I think I've given you my passion points through your questions. I hope people listening to this, that more of them will choose an engineering education, because I think it's a great path for them to take.
I agree with you there. Well, how can people get in touch with you?
Well, the Dean of Engineering at BYU is among the easiest people on the planet to find. So you Google Dean of Engineering at BYU and all my contact information will come up.
Terrific. How about if they want to engage with your company?
Sure. The name of the company is Wavetronix. That's with an X like Tektronix, so ends with an X. Again, Googling that, you will find our website and job postings and kind of what we do. So I would encourage you to go to wavetronix.com and check us out.
Terrific. Well, thank you again so much, Dean Jensen. This has been just a marvelous conversation. I've really enjoyed it myself. Thank you for spending some of your time with us today.
Well, it's been my pleasure. I've enjoyed it as well.
I'm Aaron Monker, founder of Pipeline Design and Engineering. If you liked what you heard today, please share the episode. To learn how your team can leverage our team's expertise developing turnkey equipment, custom fixtures, and automated machines, and with product design, visit us at teampipeline.us. Thanks for listening.